In this section, we will take a look at what you, as an IT professional, may have to deal with in supporting laboratory systems. Supporting laboratory work is going to be quite different than supporting applications in other parts of the company. This is a place where typical IT policies for support come up against some hard realities. As we've seen in earlier segments, the vendors vary widely in size and their product support. Keeping up with new versions of operating systems and underlying database systems may not be up to the standards that more traditional business applications provide. The vendor's first priority is to provide products that meet the user's needs, and they may choose any operating system platform they need to accomplish that goal. In a lab, you may find Microsoft, Apple, Unix, and Linux versions. IT policies that require all computers to be running the same operating system version can create issues. It may seem like a simple thing from the IT side, but there are often reports that a particular software application will break if the operating system is upgraded. The priority is that the scientists get their work done, not that all operating systems be the same. The lab staff needs to get their job done using whatever tools work. There may not be a lot of choices. As a result, you will find yourself mastering a complex array of products. Some users may have found that they need to support themselves either due to current support issues or habits gained in working with other companies. As a result, you will find the users have a wide range of IT knowledge, ranging from competent application users to those that fully understand operating systems and programming. The priority is the ability to get lab work done, and you will need to be able to develop a working relationship with lab personnel. We're going to begin by looking at how the role of the scientist and IT specialist has evolved. Initially, laboratory work was done by scientists whose primary focus was laboratory instrumentation. That is still the case today, since the instrument is a place where all measurements in the laboratory are done. Computer systems and information technology are viewed as tools to assist in laboratory work, even though they play an increasing role in laboratory operations. When computers came on the scene, their use in laboratories began in data acquisition and analysis, and the work of programming those systems was done by the scientists themselves. They were the ones who had the understanding of not only what had to be done, but they learned how to do it. The image on the screen is an early system based on the PDP-8 that had the specifications shown on the left. By today's standards, it's an extremely small system, but in its day it was state-of-the-art and expensive. The scientist was both a scientist and a programmer, who in some cases had to learn assembly language programming. He was also an electronics specialist, who was responsible for wiring the instruments into the computer system, and he was his own IT department. By the 1970s and 80s, laboratory computing had changed significantly. More commercial products were available with more sophistication than the scientists could program themselves. The scientists became less concerned with computing and more interested in how systems could benefit their work. With the advent of systems such as the National Instruments LabVIEW product, the scientists no longer had to concern themselves with the details of programming languages, but could focus on the logic of getting work done with the actual software provided by the vendor. Instead of developing everything by themselves, they could buy components and assemble systems to do the work. In the 1980s, laboratory systems focus shifted from experiments and data acquisition to sample preparation and robotics. The systems followed the same path as programming did. Initially, the scientists did all the work, again because they understood what had to be done, and it was difficult to find outside resources to do that work. In addition, many of them saw it as an enjoyable pursuit and wanted to do it. The development of laboratory information management systems broke the trend of the scientist-developer. The systems simply became too complex, and laboratory computing shifted to information technology specialists. Today, laboratory personnel and IT specialists need to develop a partnership to get the work done. Interest in things such as integrated systems, paperless environments, and electronic laboratory notebooks require expertise that the scientists generally don't have. While in the past, those using computer systems in the laboratory had to be a jack of all trades, today they're primarily scientists. There are some with considerable computer systems expertise that can handle systems development, but the majority of them are users, not developers of systems. Scientists see themselves as specialists in specific scientific disciplines, where laboratory software is simply a tool needed to control an instrument, carry out calculations, or otherwise assist in getting their work done. Although not the case in all organizations, historically, relationships between laboratory personnel and IT support groups have been characterized by a fair amount of tension. The laboratory group needs to work with the tools that fit the instrumentation and problems they're trying to solve. Information technology groups see their role as making sure that the systems are up and running and to protect it from components that could either pose a security threat or impact support costs. While both groups have their points, they're better served if they can be resolved cooperatively. This means that both groups have to understand each other's positions and come to an agreement on how the objectives of both can be met. Some laboratory users have limited PC skills. Many come into the labs with an understanding of office products or similar systems and no longer have the detailed knowledge that earlier computer users had. Some will find themselves intimidated by computer systems, particularly the large database systems that support electronic laboratory notebooks and laboratory information management systems. They need to be educated, and for the most part, that education is lacking. They can be hard to support because they, like most people, resist change. The average user is competent enough to get their work done, but could benefit by additional training, particularly improving their IT skills, and given the opportunity, they'll usually be willing to do it. They may view information technology groups as limiting their ability to make changes and incorporate new software that isn't supported by IT groups. Advanced users understand a lot about computing and software. They may have some experience in doing programming and systems development. Because of this, they can be difficult to support because they think they can do it themselves, and sometimes better than the IT groups. They may see IT policies as being limiting in getting their work done. Those who really understand computing will understand why IT has to manage systems the way they do. They may not like it, but they'll understand it. Historically, there's been a poor relationship between scientific and IT groups. The laboratory workers generally believe that IT groups don't understand what they are doing, and to a large extent they have a point, because lab work is unfamiliar to most IT people. Scientists are driven to get their work done, and anything that gets in the way is viewed as a problem. It's important to let them know that you've gone through the trouble of taking a course to better understand laboratory work, and that you're willing to sit down and learn more about how their work is actually done. You will probably have to take the extra steps needed to develop a good working relationship with lab workers, but if you do, you'll find your work more challenging, more interesting, and more rewarding, both professionally and personally. From the IT perspective, scientists can be viewed as arrogant individuals who don't respect IT support and the challenges it faces. Often, IT support specialists believe that scientists don't understand the purpose or the benefit of IT policies and procedures. There is a lot to be gained by sitting down with laboratory people, explaining why policies exist. It also makes sense to include them in the development of new policies and provide some flexibility. For example, upgrade policies and operating systems can cause significant problems. From the scientist's point of view, the computer is there to do the work they need, and the application software is the driving factor. If upgrading the operating system prevents or disrupts the operations of the application software, they can't tolerate the upgrade. If IT's policies on upgrades are going to try and force upgrade issues, you're going to have a problem. From the lab worker's perspective, that policy is interfering with their ability to get the work done. While the IT view may be that all computers have to run the latest operating system versions, and that the vendor should be expected to upgrade application software, in many cases this won't happen. As we've noted earlier in the course, critical software may come from small vendors who simply don't have the resources to be constantly upgrading software to meet the new versions of the operating systems. Today, the development of laboratory automation programs has to be a partnership. Corporate management sets priorities and determines what projects get done. It's also responsible for setting organization-wide policies and practices for project management. Basically, they set the ground rules that everybody plays by. Laboratory management determines what's necessary to improve the laboratory's operations and makes recommendations for what projects need to be undertaken. Laboratory personnel are responsible for the development and evaluation of functional specifications for new projects. They are the ones who have to live and work with the results and know best what the issues are in the laboratory on a day-to-day basis. IT support provides project planning, management, and implementation. Today, the development of laboratory automation programs' emphasis is on the partnership. The goal is to do whatever is necessary to enable laboratories to get their work done, because their work has a direct effect on the profitability and success of the company. Lab management and lab personnel know what they need to have accomplished to better enable them to get their work done. They'll be looking to information technology groups for project management support, implementation of projects, technical support, and recommendations on how to use information technology to improve their ability to work. They may want to see IT as providing a consulting service in the evaluation and development of new projects. As noted, it is possible that IT policies may conflict with lab work. IT's desire to standardize applications and operating systems may not work well because labs have specialized needs and particular application packages to get their work done. Their focus is going to be on the application, not the operating system. The way IT groups carry out support can help or hinder the development of good working relationships, and those relationships are at the core of being successful. One example is the way you support requests for help. The remote help desk model may be a useful way for a vendor to support customers, since they are often working with people in different time zones and widely dispersed geographies, but not if you're in the same building. Having the lab personnel fill out forms and documenting problems may provide a mechanism for dealing with time accounting or management issues, but it doesn't do anything towards solving the issue or improving relationships. If the lab is having a problem, they need it fixed, not filed, prioritized, and dealt with in a way that stresses a we-they point of view. They need someone to show up, to talk to, and believe that they understand that what they're talking about and that someone's willing to address the issue. Do you enjoy filling out forms to request support? Support request forms basically say, we support a lot of people and as an individual, you don't matter. That doesn't build good working relationships. However, once a relationship is established and people believe they will get the support they need, the forms wouldn't be an issue. There are places where information technologies, with the assistance of IT specialists, can provide a useful value-added service to lab work. We'll look at a few examples. One example is dealing with obsolete software. This is a particularly vexing issue and can be caused by a vendor going out of business, dropping a product, or a merger between companies with competing products. The fact that the vendor has stopped supporting it doesn't mean that the software isn't valuable or that it's useless. It might be tied to a particular instrument, for example, and could be the only system that supports it. Even if the instrument is replaced, the software would still have value because of the data it holds. While it might be possible to extract the data files, working with it could be difficult due to unique file structures that only the software understands. One way to address this issue is through the use of virtualization. This allows old software, including packages running on old versions of operating systems, to be used on modern hardware, giving the scientists continued access to both the data and a means of working with it. Virtualization, however, would not provide a means of directly supporting the instrumentation, since virtualized systems do not have access to external instrument hardware or the ability to support real-time environments. It's important to know what real-time really means in laboratory work. Here it has a very specific meaning: the ability to interact with an instrument or device without delay. If the software is doing data acquisition at 1,000 points per second, that means precise sampling every millisecond, without fail. The same time constraints may hold in instrument control systems. Things have to be carefully coordinated or they don't work. This is a problem with virtualized environments. Another example is taking advantage of the fact that you may be supporting multiple labs. People in labs are often insulated from other groups and what they are doing. It is just the nature of the work. In your support role, you may say more about what is going on than they do, including people doing the same thing in different ways in different labs? If you do, bring it up. By looking at the different approaches, you may be able to suggest a common method that works and is easier to support. You may encounter the "I'll do it my way" attitude, and sometimes it depends on how you approach people. If you tell them to change the way they are doing it, they won't. Tell them that someone down the hall or in the next building is looking at the same problem from a different angle and being successful, or having a problem, or suggest that working together could lower the cost of the project, you'll get better results. Managers, scientists, and lab staff aren't going to keep up with the developments in information technology to the extent you will. Talking to them about what they are doing, where issues exist, and letting them know about capabilities that might be of use to them would be a useful service. It might be worthwhile to arrange periodic informal sessions to bring people up to date on IT technology that might be of interest to them. Being an effective project manager is another useful role. Lab people rarely take project management courses, and the details of how to be successful in that capacity isn't part of their skills, particularly when applied to engineering programs. Being able to guide projects to a successful conclusion is a valued capability. Providing support for research and testing laboratories is among the most challenging assignments for an IT professional. Not only will you need strong technical skills, but in addition, you will need the ability to work with people who are doing state-of-the-art work. That combination of skills will serve you well anywhere.